Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on Gauss law in electrostatics. Actually, Gauss law is a simple application of the notion of electric flux. To find total electric flux through a sphere of radius r, which encloses a point charge q at its center, we will divide this whole sphere into small area elements as shown. And we consider such an element having area ds. So we will first find flux through this area element ds. We know that flux is given by dot product of electric field and area of the element. So d phi is E dot ds. But here, electric field has been found using Coulomb law due to a single charge q at this point, which is present on this surface. So distance of this surface from the center where charge is present is r. Therefore, electric field in vector form is 1 by 4 pi epsilon naught q by r square multiplied by r cap. So I will put this electric field here. So what I get, d phi equal to q by 4 pi epsilon naught r square into r cap dot ds. What is r cap? It is the unit vector along radius vector from the center of this sphere where charge q is present to this area element ds. Now, main thing is that normal to sphere at every point is along the radius vector at that point. What is the meaning of this? The angle between ds vector and r cap, they have, because they are having same direction, so this angle is 0 degree. So when I open this, it will be q by 4 pi epsilon naught r square r cap ds. Because here magnitude of r cap is 1. It is unit vector. Unit vector means whose magnitude is 1. So when I replace this r cap by its magnitude in this dot product, what I get, q by 4 pi epsilon naught r square into magnitude of r cap means 1, ds, magnitude of this ds vector will be ds, and cosine of angle between r cap and ds vector. So that angle is 0 degree. So q into ds cos 0 by 4 pi epsilon naught r square. This cos 0 is 1. So what I get, d phi equal to q ds by 4 pi epsilon naught r square. Hence, total flux through the sphere is obtained by adding up flux through all the different area elements. When we add up, we have continuous summation. So I integrate both sides, but I get phi equal to integration of q ds by 4 pi epsilon naught r square. So q by 4 pi epsilon naught r square is constant. It is taken out of this integral sign, but is left integration of 1 with respect to s. Because we divided this whole sphere into small segments, each of area ds. So when I take continuous summation or I add up all these elements, again I will get a sphere of radius r. So total area of this sphere will be 4 pi r square. So integration of ds will be 4 pi r square. So q into 4 pi r square by 4 pi epsilon naught r square. 4 pi r square will cancel. So what is left? Q by epsilon naught. This is flux through a closed surface. Hence, statement of Gauss law will be total electric flux through a closed surface enclosing charge is given by 1 by epsilon naught times charge enclosed. So phi is q by epsilon naught. This we have obtained using Coulomb law. So we have derived Gauss law using Coulomb law. But we know that flux is equal to surface integral of electric field. So this phi can be replaced by surface integral of electric field because I am taking closed surface. So I will put circle on integration sign. So it will be surface integral of electric field over a closed surface is equal to q by epsilon naught. This is another statement of Gauss law. So this may also be stated as the surface integral of electric field through a closed surface enclosing charge is given by 1 by epsilon naught times charge enclosed. Now, If Q is 0, that means no charge is enclosed by closed surface, then this electric flux will be 0. If I take example of dipole, suppose a closed surface is enclosing dipole. Electric dipole is a system consisting of two equal and opposite charges separated by small distance. So, net sum of two charges inside that closed surface will be 0. So, no net charge will be enclosed by the closed surface. In that case, flux will be 0. So, whenever you find that net electric flux through a closed surface is 0, it does not mean that it does not contain charge. It may contain charge, but net sum of all the charges present in that closed surface may be 0. So, sometime it may not enclose charge or it may enclose charges, but net sum will be 0. That is why electric flux through a closed surface will be 0. Thanks for watching this video. Like, share, subscribe my channel.